Okay, let's get started by seeing how we declare elements with schema. Now, schema is a very complex subject, and it's, again, one of those things that could probably fill an entire course by itself. So I'm not going to go into every possible feature that schema provides. However, by the end of this chapter, you should know enough to be able to use schema to generate some pretty sophisticated schema documents to validate your XML content. At the end of the chapter, we're going to see how we can use schema to build a schema file to validate our business card example that we've been using in the course. Now, as I said earlier, elements are declared using the element tag in the schema file, and elements can be declared as having either a simple or a complex type. These types can either be built in, which means they are already defined for you by schema, or your schema file can define your own custom types, and we'll take a look at that in a little bit. Just like in DTDs, you can declare elements that have mixed, empty, or element content, and elements can be given a minimum and maximum number of times that they are allowed to occur. Now remember, you can kind of do this in a DTD file, but you can't specify an exact number of times that an element is allowed to occur very easily. You could do something in DTD like define the name of an element over and over again using commas, but that's a very inefficient way of doing it, and it's not very flexible. But schema solves that problem. There's just a couple of attributes that you need to set, and that controls how often an element can occur. Elements can also be restricted to having certain values, and this is where schema really begins to show its power, and we'll take a look at that a little later on. Schema provides a set of built-in simple types, and recall I said elements can have either simple or complex types. Let's take a look at some of the simple types. Now, I'm not going to go through every one of these, but you can refer back to the table as you need to. Just taking a look at some of them, right at the top is the string type, and the string type is a sequence of allowable XML characters. There's also types for Boolean and decimal, and they get a little bit more specialized too, such as the positive integer and negative integer types that restrict content to numbers that are either larger or less than 0. There's a type called any URI, which restricts content to being a URI format. You've also got some more specialized types, things like dates and times and date times, things for the Gregorian calendar, so they get pretty specialized. Okay, let's take a look at a couple of examples of declaring elements. Here we have two examples. The first one declares an element that has the name of name, and its type is a string. And the second one has an element name of higher date, and that one has a type of date. When you declare these in your schema file, the corresponding XML file would contain elements named name and higher date, and they would be restricted to having, in the first case, string content, and in the second case, they would have to match the format for a date. You can limit how many elements appear in an XML file or inside a particular XML element within that file by using the min_occurs and max_occurs attributes. Now, the default value for each of these is 1, so just like in DTD, if you don't define these attributes, then it's assumed that the element can appear at minimum once and at most once, so you have to have exactly 1, and each one of these attributes is optional. In the first example there, you see that there's an element that I'm declaring named friend, and it has a type of string, and it has a min_occurs of 1, and a max_occurs of a special string value named unbounded, which means that there's an unlimited number of these friends tags that can appear in my XML data. In the second example there, you see that there's an element named phone, and that's also a string type, and in this case, there is no min_occurs elements, so it's assumed to be 1, and the max_occurs attribute is set to 5, which means that we can have a minimum of 1 and a maximum of 5 found elements. Now, you can define your own custom simple types, and the way you do this is derive them from the simple types that are built into schema. Let's take a look at an example of how you would do this. Suppose we had an element in our XML data named invited guests, because we're putting together XML data for a party event. Now, we could just specify the type of this tag as a positive integer, but the problem with that would be that the positive integer allows you to specify a value all the way up to, a really large number. And I doubt you're going to be inviting the entire planet to your party, so you probably want to provide a much more tight restriction on the number of invited guests. Now, the way that you do that is inside the element, you use the simple type tag, and then inside there, one of the things you can do is use the restriction tag to declare a base value for how you're going to restrict the value of the tag. Now, in this case, we're saying there's a restriction based on the positive integer type. And inside the restriction, we're using two tags, min inclusive and max inclusive. And each one of those is assigned a value. There's 0 and there's 50. Min inclusive and max inclusive define a range, in this case, of allowable values for the number of invited guests. The word inclusive means that those two values, 0 and 50, are included in the allowable range. So any value between 0 and including 0, up to and including 50, would be allowed for the invited guests element. If we didn't want to include the 0 and the 50, instead of using min inclusive and max inclusive, we would use min exclusive and max exclusive. And in that case, the two values there would not be included in the range. You can also restrict content to allowable choices. And this is something very similar to what we saw in DTD. Now, in this case, suppose we have an element named dwelling, and we want to restrict it to one of a number of allowable choices. Well, you can see here that inside the simple type tag, I've got a restriction, and in this case, I'm basing it off of a string type. And instead of using the min and max inclusive, now I'm using these enumeration tags to enumerate the allowable values for this dwelling tag. And here I've got values such as house, apartment, trailer. The XML data is allowed to contain one and only one of these choices for its dwelling tag. It gets better though. You can actually restrict content of elements based on patterns using what's known as regular expressions. In this case, we have an element and its name is SSN for Social Security Number. And again, we're using the simple type tag here to declare our own custom type, and we're using a restriction which is based on string. In this case, however, the restriction is a pattern specified here by the pattern tag. The value attribute of the pattern tag defines a regular expression. And if you're not familiar with regular expressions, they are a way of writing strings that define a pattern of characters that are allowed to appear for a given value. Regular expressions are a subject all their own, and I'm not going to go deep into this. There's a title right here on lynda.com that deals with regular expressions, so if you want to learn more, you can go watch that title. But in a nutshell, this pattern means that the content for the SSN tag is restricted to a string that matches the pattern of 3 digits, followed by a dash character, followed by 2 digits, followed by another dash character, and then followed by 4 digits. And that's the pattern that fits a US Social Security number. And any value that's supplied in the XML data for this type would have to match this pattern. Okay, so that's pretty much it for simple types. Let's take a look at how you declare elements with complex types. Now, there's 2 ways to do this. You can use the any type for the type attribute in your element tag. So if you define an element and inside the type attribute you specify XSD any type, it pretty much means that the content of the element is not restricted in any way. However, you can also use the XSD complex type tag in the definition, and this is the counterpoint to the previous examples where we were using the simple type tag. Let's take an example. So how would you declare an empty element inside schema? Using schema, we have here an example of an empty element, and the way this works is using the element tag. So the name of this element is empty elem, and so I declare this element as being empty. You simply put an empty complex type tag inside the element declaration. We're leaving the content model for this element empty, and that's it. That's how you declare an empty element. Like DTD, however, you can also declare elements that have mixed content. And in this case, I'm declaring an element named title, and I want its contents to be mixed, which means it can contain both character data and other elements. Now recall earlier from the DTD section, it's possible to declare elements that have both character data and elements in them, and schema is no different. In this case, I'm using the complex type tag, and to declare it with mixed content, all I need to do is put that mixed equals true attribute you see in bold there on the complex type, And then inside the complex type, I can use the sequence or choice or any other schema declaration tag for how the content model is going to look. Now, in this case, it's a sequence, and we're defining a sequence of subtitle tags inside the title tag. Now, since I didn't use the min occurs or max occurs attributes, it's assumed that only one subtitle is going to be allowed inside that title element. I could use the min occurs and max occurs to change that, however. You can also declare elements that have element content inside them. And again, this is very similar to DTD, and we can do that using one of three methods in Schema. The first is a sequence, which we just saw an example of in the previous slide. The next is choice, and then finally there's a method called all. Sequence essentially means that the child elements have to appear in the order in which they're declared. That's again very similar to the way DTD works with commas in the element declaration list. Choice means that any one of the elements that appear in a list can be used. And again, if you remember back to DTD, that's where we had the vertical bars to separate element names. And then finally, the all option means that, the elements of a given element can occur in any order. So let's take a look at each of these. Here in this example, I've got an element that I'm declaring, and its name is address. And inside the address element, I'm declaring that it's a complex type, and the address element is made of a sequence of other elements. Now, inside the sequence declaration there, I've got four elements: num, street, city, and state, and they're all declared as strings except for the house number. And again, I'm not using the min or max occurs attributes here, so each one of these tags is going to appear exactly one time. But of course, I could change that using those attributes. Now, the next option available to us is the choice. Here I've got an element I'm declaring named vehicle. And again, it's a complex type. And inside the complex type, I'm saying that the elements that can appear inside the vehicle definition are one of the following list. A vehicle can be a car, bus, van, or truck, and so on. I could go, of course, and change. I could add more to this list. But the point here is that the element that can appear inside vehicle has to be one of the things from this list. I couldn't say motorcycle here, for example. Finally, I can use a declaration that says that certain elements can appear in any order inside of the given element. So, for example, here I've got an element that I'm declaring, and its name is capital city. And inside the complex type tag, I'm using the all tag. What the all tag essentially means is that the elements that are declared inside the all tag can appear in any order. For example, I've got the name, state, and population where the capital city appears. I'm declaring them. There are different types. There's a strings and positive integer. And again, I could use min and max occurs to control how many of these there could be. However, in this case, since they're not declared, there's assumed to be one of each. Okay, that's pretty much it for elements. In the next section, we will take a look at declaring attributes using schema.